Righty, let's get the show on the road. Hey, everybody. My name is Stephen Feuerstein. I'm the developer advocate for PL SQL here at Oracle, and I'm joined by Chris Saxon, who is the developer advocate for SQL and really all things database. I'm going to show Chris off too. There's Chris.
Yep. Hi, everyone. Good to meet you.
Thanks for joining us for our latest office hours session. What I'm going to do is first do a little presentation on table functions, one of, I think, the coolest features of PL SQL, and cover the basics. And we've got a couple of questions queued up that have already been submitted. Feel free to queue up your own questions in the chat box as well. Please do follow us on Twitter, LinkedIn, Facebook, you got it, whatever. The whole point beyond office hours, and really the jobs of developer advocates like Chris and myself, and all of the product managers and developers at Oracle database team, are to help you be successful with Oracle database and all the amazing features we pack into it for application development. So the office hours program from AskTOM is one of the biggest parts of this. It's a wide open pipe of communication between developers and evangelists and other experts at Oracle to our users. Every month, dozens of sessions, taking your questions, learning about new topics in Oracle database, especially. Table functions are functions that act like tables and queries. You literally select from a function. Now, of course, functions return stuff. So what you're really selecting from is the stuff being returned by the function. And table functions return collections or array-like structures from PL SQL. And then the magic of the SQL engine and the table function, the interaction between SQL and PL SQL, means that the SQL engine takes the collection data set returned, turns it into rows and columns as if it were a table or a view, and then off you go. You can select from it, you can join, you can union, you can do all sorts of fun stuff. So here are just a couple of really simple little examples right here. So select from table. So the table keyword indicates that we're calling a function, and then SQL is going to do the conversion out into the result set. You can, of course, pass in parameters. They can be any kind of parameter that's consistent with the SQL interface, SQL data types. For the simplest form of table functions, in which you're returning just a collection of scalars, a list of strings, a list of numbers, and so forth, Oracle provides a fixed column name, column underscore value. You can change it to whatever you want with an alias. As of 12.2, hopefully you're all on 12.2 and aching to get onto 18C, and soon the free XE version of 18C will be available. As of 12.2, we made SQL a little bit smarter, so you don't have to put the table clause around your function. We figure out that it's a function. We put the table clause around it for you. Isn't that nice of us? And then as a little other example here, let's see, can I make that go away? I can make those lines go away. I just have to remember how. And then you also have a special kind of approach that you can take with table functions that are called streaming table functions, in which you take data and you pass it along through multiple transformations. You stream it along through multiple transformations, all in the same SQL statement. This is an approach that's commonly used in data warehousing. And for that situation, we have what's called the cursor expression in SQL. And that takes a select statement, literally a select, not a dynamic SQL, a select statement, converts it into a cursor variable, passes it into the function, do all sorts of wonderful stuff, pass it back. We'll look at some examples. As I say, very cool. Now, you might say, well, why would I use this thing? So first of all, fundamentally, table functions are about programmatic construction of a data set. So rather than simply writing it in SQL, and you certainly, if you can write it in SQL, just write it in SQL. In fact, I'll come back to that. You might write it in SQL and put it inside a table function. But there are also situations where you might have a very complex algorithm that determines the data set you want to display. And you can't write it in SQL. So you can build it inside your table function, populate the collection, pass back the collection, and treat it as if it were SQL. Now, in these days of using REST to make calls to other data sources and integrating them all together, one clear use case for table functions is to actually access external data outside of Oracle database through a REST call or maybe some other Oracle database. Pull it into your function through the REST API, and then do whatever manipulation you need to do on it, and then pass it back into your SQL engine. And if you want to see an example of that or something similar to it, check out this URL. In fact, I'll publish all of these slides afterwards on SlideShare, tweet it out on my Twitter feed, and add it to the AskTOM Office Hours session. But you can see an example of accessing the Kscope, ODTUG Kscope sessions for the Kscope conferences. loading it into Oracle through a table, making it available in SQL through a table function for really flexible querying. Now, another use case for table functions is perhaps not the ideal, but it's the real. People like Chris Saxon and Tom Kite and lots of other people, Kimber Kansen, who's the quiz master on the Dev Gym for our SQL quizzes, they can make SQL get up, dance, spin around, jump around, and do whatever is needed to get the job done. And it's amazing what they can do with SQL. But we're not all like that. Some of us have more limited SQL skills. You're looking at one of those people now. So sometimes I try to get it done in SQL, and then I send a note off to Chris or Connor McDonald, the other AskTOM SQL master. But they're not always available, and I don't like to ask them too often. So sometimes I will fall back on PL SQL as the mechanism, as the compensation for not being able to write it in SQL. And you could say, well, Stephen, you should know SQL better. And it's true, I should. Probably the same for all of you. But you all know your time's limited, and you have to get the job done. So don't feel bad if sometimes you hit the limit on your SQL skill set and you say, you know what, I'm going to fall back into a table function and get the job done. It's okay. We've all been there. Now, hopefully you've heard of SmartDB. It's an architecture, a design for building applications on top of Oracle database that makes full use of the Oracle database, not just as a persistence layer for your data, but as an actual enabler for application development, improving security, performance, and maintainability. Check out our SmartDB office hour sessions if you're not already attending those. And in the SmartDB architecture, developers never write SQL. They're always accessing a PL SQL API. So in this case, table functions become the primary API through which you access queries. You might write your query, put it inside the table function, select from that table function. And then a specific type of table function is the pipelined table function. And you can use this variation of table functions to greatly improve performance, minimize memory usage, sometimes very dramatically, over normal table functions. So those are pipelined table functions. Cruising right on along because I want to get through cover the basics, show you some interesting stuff, and get it onto our questions. So some things to remember about table functions, some fundamentals. The function must return a collection. It's usually going to be a nested table, rarely a V-array, because that's limited in size. You can use associative arrays in some circumstances with pipeline table functions, but almost always a nested table. It can be a collection of scalars, a list of strings or a list of numbers, but sometimes you want to return multiple columns of information. In that case, you can use an object type based on, or a nested table based on an object type. The function has to be visible to the SQL engine. You can't create your function locally inside an anonymous block and expect the SQL engine to know about it and resolve the reference to it. So it's got to be either a schema level create or replace function or in the package specification. And as I mentioned, pipeline table functions can be used to improve performance and reduce program global area memory consumption. Now, I could bring up SQL Developer, show you a lot of different files, run a bunch of scripts, then you want to know where are those scripts, how do I do this stuff myself? You can use LiveSQL. So livesql.oracle.com, and I'll go to that website in just a second. I should have put the URL here, livesql.oracle.com. Provides a really great way for me to share what I've learned to know about PL SQL and table functions in SQL, and others as well, Chris Saxon and Connor and so forth. All contribute dozens and dozens, overall hundreds of scripts to LiveSQL that you can use. So if you go out there and look for table functions, you'll find 28 hits, a lot of them on polymorphic table functions. Didn't even mention those. Chris is going to talk about them soon, new to 18C. And even some tutorials that I built that ties into a DevGym class. Let's take a look. Okay. So first of all, let's go over to the DevGym. devgym.oracle.com. Lots of classes and quizzes and workouts on Oracle database technology. And you'll see here, get started with PL SQL table functions. So if you're new to table functions and you want to explore them more and you can watch some videos, read the tutorials, take the tutorials in LiveSQL, take the quizzes, get a certificate when you're done, check out, get started with PL SQL table functions. All right, I go to LiveSQL. Now right at the home, so livesql.oracle.com, I can just search on table function. And you see there's a lot of stuff out here. And I encourage you to go exploring and see what you can learn from LiveSQL from all these different examples. If you focus that a little bit more, let's say get started with. then you'll see my 4 different tutorials that go with my DevGem class. I'm going to show you the tutorials today, but I do encourage you to sign up for the class and get the full experience. So, Module 1, Overview of Table Functions, just to show you some really basic stuff. Let's make this bigger. Here's an example of a really silly table function. So I'm going to create a nested table type at the schema level, create or replace type. It's a list of strings. I'm going to create a function called random strings. Give me 5, give me 10, give me 100 random strings. And it uses DBMS random string to generate those. Populates the collection, returns the collection. And as you're about to see, I can run it in PL SQL. So insert into my editor. There's all my code. I run my code. Don't do that. Okay, let's refresh my session. Sorry about that. I needed a drink of water anyway. Okay. So let's insert into the editor. Let's run this. And there you see, the type was created, the function was created, and 5 strings. So here you see, here I see 5 strings. Yep, 5 strings. So I called my function, displayed the output. So this is just in PL SQL. I created a table function, but I didn't use it as a table function, but I can. So let's now take that table function and use it in SQL. So get me 5 random strings. And by the way, another thing I should have mentioned in use cases is that you can think of a table function as a kind of parameterized view. We don't support views with parameters, but essentially you've created that by having parameters in your function. So select all the column values. That's the hard-coded value, and I can rename it. For my 5 random strings, I can use name notation. I can perform SQL operations on them. Let's run this. And there's my data, right? So now I took that same function that I ran in PL SQL, and I ran it directly in SQL, just by adding the table clause or again, as of 12.1 and higher. I think it's 12.2 actually. You don't need to put the table clause around your call to your function. All right. So the other thing you can do is blend things together. So for example, in this step, I've got a combination of data that I'm generating in my table function, but I also might have data in my other table. So I've got data from my persistent data tables. I've got data from my table functions. I can union them together, join them together, do whatever I want. I can even create data sets inside my PL SQL code, merge them together via the table function. So lots of different ways you can play around with table functions. Okay, so that's the basic introduction to table functions, and this is a very simple example of collections of scalars. Let's move on to something a little bit more interesting, which is returning multiple columns. And I will refresh so we don't run into that same problem again. Thank you very much. So it's often the case that I have multiple columns of information that I want to return from my table function. In that case, things get a little bit tricky. Sometimes you'd like to say, well, just create a nested table, a collection of animals % row type, but you can't do that in SQL because that's a PL SQL data type. So what you do instead is create an object type. This is part of the object relational model that most of you probably don't do anything with, and you don't need to know much about it. You don't need to do anything object-oriented with it to use this feature here. But I simply mimic my tabular setup or a record structure. Set up the multiple columns that I want to have returned by my table function. I create the nested table or collection type of that object type. And then inside my code, what I will do is construct my data set. And I construct the data set by calling my object type constructor, passing whatever data I've constructed. Obviously, this is pretty random stuff. And I make room in my collection, add it to the end of the collection. And then I've got my collection of object type instances that I can return. Let's step through this. Let's create my function. And as you can see, if you're a rabbit, you have 12 babies. If you're a dog, you have 4. If you have a kangaroo, just 1 at a time. And then I'm going to use that table function. So I'm going to call, look at this, select name, species, date of birth. Where do these column names come from? From the attribute names of the object type. I call my animal family function, and I'm going to pass in two parameters, the mom and the dad. So I'm constructing an object type on the fly and passing them in. These are the two different parameters, the mom and the dad. Run my code. Run my code without highlighting. And there's my family. And they seem so happy. Lots of baby rabbits. Okay, so that's the basic idea with a more complex situation. Create the object type instance, nested table of the object type, function returns that nested table. Cruising along. Let's refresh. So let's take a quick look at streaming table functions. So in this case, I've got a situation, usually in a data warehouse, where I've got one set of data that I need to pass through one or more transformations into a new data set. Now you could write a PL/SQL program to do that, but it's often much more efficient and simpler to stream it along through multiple transformations with table functions. And I'll just go through this pretty quick. The main thing to know about, here's an example. I'm going to take the data from my stocks table and do a 1-to-2 split into the tickers table. It's a very simple operation. You could do it in SQL. Anyway, what I'm going to do is take all the data from the stocks table and pass it to my doubling function. And then I'm going to grab all the data from my doubling function and insert it into the tickers table. And you could have multiple iterations of this all within that same statement. And the key thing here is to notice that I'm not passing in a dynamic SQL statement. I'm literally passing in the select, the data set returned by the select statement. The cursor expression takes that set of data and converts it into or points a cursor variable to it. And the cursor variable is a data type that within your PL/SQL function you can iterate through and then build out your data set, which is what I do right here. Here's an example of a double transformation. Take the data from this table, transform it, turn it into a data set of rows and columns, select from it, pass that as a cursor variable into another transformation function, etc. I won't go through all the steps of running this. The main thing is that if you take a look at, here's my object type of tickers, mimicking the ticker table. In the table function itself, I'm going to pass in a ref cursor. That's the cursor variable coming in. That's defined in my package specification. I can fetch from that cursor variable. I usually move it into a local array using bulk collect to improve the performance inside my table function. And then I iterate through that array and I populate my outgoing function for the table function. I return my doubling. So here's my one row for each row in my stocks table, turn it into 2 rows into the tickers table. But the main thing here is to know about defining a ref cursor type, using the cursor expression to pass in that result set in SQL into the PL/SQL function for programmatic manipulation. All right, last one. Pipeline table functions. Pipeline table functions are really curious entities in PL/SQL. The biggest thing that makes them curious is that they support asynchronous execution. In general, when you call a PL/SQL function, everything stops, or a procedure. Everything stops and blocks that session from continuing until that function completes and returns data, or the procedure reaches the end of its executable section and returns control. It's a blocking mechanism. There's no multi-threading in PL/SQL natively. With a pipeline table function, the basic idea is that as your table function is generating data, and it was called from a select statement, it's passing the data back, it's piping it back to the calling query. The calling query can use that data, and this is especially powerful in a parallel query situation, again in data warehousing. The calling query can utilize the data in that pipeline table function while the function is still generating more data. Another way that this can be used, I haven't done it myself, but I've been told that they've done it, is that you might be returning a very large data set to a web page. And users don't want to sit there and wait while the scroll bar gets smaller and smaller and smaller as the page gets longer and longer and longer. So with a pipeline table function, you can immediately be getting like the first 10 or the first 100 rows, displaying them. And the table function is generating more data as your user's seeing the data, and they're happy to get started with the data, not waiting several seconds or a minute or whatever it is. Okay, so the basic idea behind pipeline table functions is that they look really weird. Here's the simplest pipeline table function I could come up with. I've got my nested table of strings, and I'm going to return that nested table type. just like the usual table function. But I'm going to say, hey, this one's pipelined. And then inside the function, there are two really odd things to notice, or I guess three. Number one, I'm not declaring any variable that I'm going to return, which I would be doing in a normal table function. I would say the local variable, let's go back. Here's my local variable of the same type that I'm returning. I fill it up and I return it. But with a pipeline table function, none of that. Instead, what I do is call this funny thing called pipe row. Whatever I'm going to put into the collection, I simply call pipe row to send it back. And usually this is a loop, not a single statement. So you'd be looping through your data set, you'd be piping the data back. And then at the end, check this out. Is this weird or what? Return semicolon. You don't return any data with the return statement in a pipeline table function. You just return control because you've already returned all the data. Let's take a look at a more interesting example, essentially the pipelined version of that 1 to 2 doubling process. So let's go right here. I know I'm kind of moving through this fast, but it's all on LiveSQL. Just come back and check it out. I've got the annotations, the descriptions, run it yourself. What a lovely world we live in today. Okay, so here's my doubling function. I pass in my cursor variable. It's pipelined. I fetch n number of rows, 100 rows at a time from my incoming data set. But instead of creating the two different rows and putting them in the collection, I simply say pipe it out, pipe it out. And notice I'm piping out an object type instance. When I get to the end, I return nothing. So that's what a pipeline table function would look like. Why would you want to do this? Are you having trouble hearing me? Hopefully not. No, okay. So why would you do this? Two fundamental reasons. One is performance. If your calling query can utilize that data as it's coming back, consume it, and use it as part of its analysis, you can have a great improvement in performance. And this is especially important in parallel-enabled queries. The second thing is that you can greatly reduce the amount of PGA memory consumed. So let's go back to the non-pipeline version for a second. Whenever you work with collections, you need to be worrying about or be aware of program global area or PGA memory consumption. That's per session consumption. When I declare a collection and start filling up with data, it consumes potentially a whole bunch of memory to do that. Megabytes, tens of megabytes, depending on how large your data set is. That can cause problems, especially if multiple people are calling that same table function at the same time. Per session memory. But with a pipeline table function, the data just comes back immediately. So there's literally no incremental PGA consumption by a pipeline table function. That alone is probably a good reason for you to, pretty much as a rule, always set your table functions to pipeline, even if the calling query cannot take advantage of the asynchronous return of data. You're still going to reduce the burn on PGA memory. The only downside for the pipeline table function is that you cannot call it in PL/SQL natively. So if we go back to that very first script, where I showed you how I could call the function right here, I created my function, and just to show you I called it inside a PL/SQL block, no SQL there. You cannot do this with a pipelined table function. It can only be called inside a select statement. Again, the SQL engine has the mechanism for taking that data as it comes back and using it. The PL/SQL engine has no way of doing that since it's not multi-threaded in any way whatsoever. All right. So that covers my pretty rapid fire introduction to table functions, covering some of the highlights, hopefully getting a sense of the kind of wonderful things you can do with it. You can go to LiveSQL and explore all the different scripts there and the tutorials. Go to the DevGym class. And by the way, if you just go to the AskTOM Office Hours page for this session, you'll see that there's a link. There's a link to the DevGym class, and I'll be adding a link to these slides as well afterwards. So you can always come back to this page as a kind of resource center for your table functions analysis and learning.
So we're getting some questions coming in now, Stephen. So we'll start with a more interesting one. It says, is it possible to create a fast refreshing materialized view based on a pipeline table function? If yes, how would I make one?
Chris, what do you think?
I would have to double check, but I'm pretty certain the answer here is no. And that's because, as you're kind of alluding to, Dennis, you can't create, there is no table to create materialized view log on. And the materialized view log is how materialized views know to do a fast refresh. So you could create a complete refreshable one, or is it? Yeah, because
there's a LiveSQL script to show you that one. There was a question on Stack Overflow. So materialized view built on table function, you can certainly do that.
Yes, but I think that one of the things you're interested to know is about fast refreshing, isn't it, Dennis? Which I believe is not. I'd have to be checked to be certain, but I believe isn't possible. I don't know if you know more about that, Stephen. Or...
I do not know. We'll check it out. If we can figure out anything different about it, we'll let you know via Twitter.
Yeah.
Okay.
Okay, and we had another question come in. Since each table function returns a collection, can you suggest any best practices for handling those types so a database doesn't wind up with dozens of table of varchar2 or table of number types?
That is a good question. So, and it's not just a question about table functions, it's a question about managing your types. So let's go over to SQL Developer. Let's see, my biggest challenge is remember the names of my files. So the concern was, let's say I'm doing lots of different table functions, and different table functions obviously return different types of stuff, but maybe over and over again, I find myself returning a collection of strings. Now you could say, I should have a separate type for each one of those different collections of strings because the contents of the strings are different. So they could be last names T, they could be first names, they could be company names. So one can make an argument that I want to have a separate specific type for each individual use case. On the other hand, it really doesn't make sense if the data type is literally the same, table of varchar2, table of varchar2, to have them over and over again. Again, this is not just for table functions. Even across your regular application code base, there's no point in repeating literally the same structure. So one approach you could take is having a separate collection of types, your centralized collection types or general types. They could be subtypes, they could be record types, and you predefine a bunch of them. So that's one approach you can take. Another approach you could take, at least for associative arrays, is you could use pre-built DBMS SQL types like number table, varchar2 table, etc. And then you don't have to create your own. For associative arrays, they won't work too well with most table functions. And also, I wouldn't use a predefined DBMS SQL data type unless you were doing dynamic SQL. That's confusing. So I would say come up with generic types, and you might keep them in a central container like this. But for anything like object types, I would certainly make them specific, keep them separate. Hopefully that answers the question, Eric. Right. And then we have a question about polymorphic table functions. So let's go back over to PowerPoint.
Okay.
Let's go into our question. Actually, we just had one more thing in chat. Regarding managing collections, we need to keep nested tables in the schema level rather than packages. Yes. So you will need to keep your create a replace type for nested tables for your table functions would be at the schema level. Thank you. Thank you, Praveen. Okay, so let's see. We had two questions that came in advance. And since we had a question come up, let's do the pipeline table, the polymorphic table function first, then we'll come back to the other one, Chris.
Yep, sure. That sounds good. Okay, so you want me to take it away on this one?
Yep.
Yeah, so polymorphic table functions. So this is a extension or to table functions that came in 18C. And the basic idea behind them is it allows you to actually manipulate the columns that appear in your result set. So with a traditional table function, you're adding or potentially removing rows from your result set. Whereas a polymorphic table function, what you can do is add or remove columns from your result set. And there are a number of different reasons why you want to do this. A basic one is if you just want to exclude some columns at runtime. So this allows you to do something which every now and again people ask is they want a select star except. So return me all the columns in the table except these ones. And what a polymorphic table function allows you to do is something like that, when you can say, I don't want these particular types of columns to appear in the output. But it also allows you to generate new columns, let's say, so taking your input and the values that there are in each row, add some new columns to the output. And at this point, I will hop over to my slide slides briefly and to talk about how this works in a bit more detail. And this kind of actually relates to the question that the person had. So they wanted a kind of dynamic CSV to columns converter. So you've got a comma-separated list of values, and they wanted to actually split that from one big string out into individual columns. And what I did, and there's a LiveSQL example of this, but I'll just kind of walk very briefly through. Polymorphic table functions are a big feature, and there's a lot more to them than we can really cover in the time that we've got now. But so what I've got, you see what I'm passing in, I've got my function CSV to columns, and what this does, we're actually passing the table name here. So this is an external table, and what we want to do is say we get these columns C1, C2, and C3, and what it does is it reads the row values out and generates those columns. So now I said, okay, well, I've got 3 columns. What I actually wanted was 4 columns from the results. So we'll do that and run it again with C4. It now generates that column as well. So this is kind of taking that individual string, and inside here, it's using string manipulation to split the values out into their individual columns. So that's kind of the principle. You're taking a table and adding or removing columns to its output. So how do you build it, or how do you actually create one? Well, there's 2 key components you need. First up, you need to create a package, which is the engine of your PTF. So this is the implementation for it. And within that, the first thing that you absolutely have to have is a describe function. This tells the database which columns will or won't appear in the results set. So you pass in the table name, and then you can pass in any other parameters that you want to manage what your output's going to look like. You can pass in here actual list of the columns. So this is our table. I want to show these columns or do something with these columns. Or as we can see here, what we've got is column names, a CSV list of columns that we're going to use to split out and generate the result set. So that tells the database what the result set's going to look like. Next thing you need is the actual fetch rows procedure. And what this does is assigns the values to each row. Now, if you are creating new columns in your result set, you almost always want a fetch rows procedure, because otherwise every row for those new columns are going to be null, or they're going to have a constant which you've assigned in that describe function. So as you're going through the rows, the fetch rows will assign values to your new columns. So that's kind of the basis of it. The next thing you need is the actual PTF itself, polymorphic table function. You can build that in the package, or you can create a standalone function like this. So we've got this new syntax, the row polymorphic using CSV package. So what this is saying is bind this function to that package. So as you recompile that package, change its definition, the way the function works will change as well. So you can have row or table polymorphic. So row operates individual row at a time, each row in the input, and table is for if you want to do kind of analytic style operations that go over multiple rows. So that was the very brief introduction. As I said, I've got the actual LiveSQL example of this. I'm not going to go into complete detail here because there's a lot of stuff going on here, but basically one of the things to note is there's this new DBMS TF package which has a lot of functionality in it. So we take a very simple example. All I want to do is add 3 columns to my output. So that's all this PTF is going to do. So we've got a describe function that looks like this, and what we're saying is we've got 3 new columns, column 1, column 2, and column 3. And this is going to go in the package. I'll then create the PTF, the function, add 3 columns. So we can do that, and we pass in dual like that, and we get 3 columns with no values in their output because I didn't have a fetch rows procedure to assign them any values. And
Chris, can you go back one slide?
Yep.
I just thought it'd be worth pointing out what is that interesting 1 equal greater than syntax thing? What is that?
Yep. Okay. So hang on. If we go on a bit further, so this is another new thing that's come in 18C, because if you think about it, what are these? Well, as Stephen's going, well, they can't be parameter names. This can't be names of parameters to a function. Why not? Well, they start with a number, and parameter names are identifiers in Oracle database, which if they've not got quotes around them, have to start with a letter. So what's going on with these? Well, these are qualified expressions, also known as array or record constructors. So something else that's new in 18C. So you've now got implicit constructors for your array and record types. So in the past, if you've got a table of varchar 2, you wanted to create 3 elements for it, you have 3 separate statements. Now you can do it all in a single statement. Same principle applies for records as well. If you've got a big record with loads and loads of fields, different attributes, individual statements, set them up one by one. Now you can just have a single constructor, one statement that assigns all the values all in one go. So that was kind of the very quick introduction to PTF. I see there's a few questions or comments that have come in while I've been talking.
Yeah, what if there's some other subroutines in the package? Would it still be okay to base a PTF on it?
So you may, there are a few other defined procedures you can have in the package. So if we go back, but
I think what he's asking also is that if you add other stuff, it's not going to disrupt the API usage, is it?
I'm not sure. I think if you've got private procedures, I'm sure you're fine. But I think actually when it comes to public procedures or functions, there is a defined list of things. So there's a describe, there's a fetch, there's open and close, which you can also use and are useful in some circumstances. And I think there's another one, which I forget. I'm not sure if you can expose them publicly.
And so Dennis, that's an interesting question in the sense that it falls into this classic bucket of, haven't thought of trying that. Now, we can try that. We probably will. I bet Chris and I will both get off this call and try to knock something together. But I encourage you to also give it a try yourself, because that's a great way to learn more about the functionality, and you can post it as a LiveSQL script. Thanks. Exactly. Joseph says 18.1 supports non-leaf polymorphic table functions. Are there any plans for supporting leaf PTFs?
So,
could you explain?
So this is an area I'm a little bit shaky on myself in terms of, because there's a whole hierarchy in terms of a polymorphic table function and the actual functionality it exposes. What I will say is that this is kind of version 1 of polymorphic table functions. If you look at the SQL standard, they come up with a couple of use cases, which as far as I'm aware, we don't yet support. One is dynamic pivot. So you can say, I want to pivot on these on these values and generate these columns dynamically. Something that isn't really possible currently. And the other is something called top n plus, where you say, I want top n first 3 values. So I want to see the first 3 values, for each country that we sell in. I want to see the most highest valued customers and the value of their orders. And then I want a bucket for everything else that goes after this. So for each country, we're seeing the 3 most popular rows, either in terms of number of orders or volume of sales, and then bucket everyone else, tens, hundreds, maybe even thousands of customers all into the same final bucket. As far as I know, these are not possible in our current implementation. And we do have plans to kind of extend this functionality further. As to when it happens, I don't have insights to the exact timescales on that. Hopefully with our annual releases that we've got, it won't be too far away, but I don't know anything more than that on that.
Now, couldn't you just take the data returned back by the polymorphic table function now and do your SQL analytics on it to get those kinds of results?
You can do SQL analytics on it for those kind of things. I think it's kind of baked in to the PTF itself in terms of the results. And it's worth noting as well, you can actually do analytics style processing within your PTF. So it allows you to pass in partitioning clauses to carve up your data set. So you've got with your traditional count function, you'd say over partition by customer to get the count by customer. You can do a similar thing with PTFs. I don't have a, I think if you look on LiveSQL, there probably is an example, but I'm not aware of one handy.
Okay. So here's another question that came in. It's a common one around table functions, and I'm going to give this one to Chris as well.
So, yes, is there a way to tell the optimizer which query inside of a table function to use? So this is an interesting question because it suggests that someone's building a table function which actually has multiple different queries within it, which sounds a bit like a kind of slightly fishy thing to me already to start with. Now, it might be that maybe you're dynamically constructing the where clause or something like that. But if you kind of got like a table function and you're using it to kind of return any query, I think you're kind of abusing this feature and using it for something it's not really intended for. So that's kind of first kind of caveat or kind of warnings there. But the next kind of then point on after that is it's not so much telling the optimizer what query inside the table function it's using. It's about how many rows it returns. And this is an area where it's, doesn't do very well currently. So essentially what we do is kind of take a guess and say, well, we think it will turn a block, worth of data, 8,000 odd rows. And quite often with these table functions, you're going to be returning substantially less than 8,000 rows. So as a general principle with the optimizer, if the estimates or the row estimates are wrong, significantly wrong, the plan is likely to be bad. So what you need to look at is how you can kind of improve the estimates here. So there are some hints available. There's cardinality and optimate estimate. Both of these are undocumented and has the general kind of, you shouldn't really use hints warning applied to them. So, they are available, but probably not the best way to go. What you can, so is this your question, Dennis? I can clarify. Yeah, I didn't mean several queries in a function. I meant that the plan inside for the query inside it is quite fixed. But the optimizer still doesn't know it and chooses a bad plan when you put your function, your pipeline TF inside another query, which Apex
so I think
does.
So Dennis is basically saying, look, my table function is a representation of this query. The query has an optimized plan associated with it. How do I get that plan out to the consumer of the table function?
So I think the thing is the query inside the table function is kind of a black box to the optimizer. Obviously,
the optimizer will use it to execute that SQL statement. So the SQL statement's been optimized, but right?
Yes.
Yeah.
So the optimizing of the SQL statement within the table function is kind of different from the results it gets out to joining it to your other data set, essentially.
So there are two separate issues. One is making sure that your SQL inside your table function is well optimized. If there is a SQL statement inside of it, there doesn't have to be. And the second one is how do you inform the optimizer that it's invoking a table function and you want to tune up its optimization? Two separate things.
Yes. So so Dennis, do you have a situation where the query inside the table function is
here it comes.
When I call the TF separately, it's okay, and the plan is great. Okay, and then it takes an eternity to run. Okay, so is this a Apex adds code? Okay, do you know? Have you got able? Yeah.
Here, Dennis, let me ask the question this way. If you take that same select statement and simply execute it inside a process in Apex, it probably doesn't take a long time. It's probably got to do with the pagination and so on in Apex.
Query out to the page. However, most of the time they work fine. It was going wrong. It was running poorly. Yeah. Yeah. Thanks, Judith, for sharing that link on stats and table functions. So I think what you kind of need to do is start with the debugging. Obviously, does the SQL statement itself work? Then does calling the table function, how does that form when you run it normally? And then need to start looking at kind of tracing your session and seeing exactly what it's doing. Now, I don't know precisely how Apex handles these table functions in their processing. I don't know if you know more, Stephen.
Well, there's nothing special in the way it handles table functions, so far as I know. I think what's being alluded to here, and Dennis mentions it with the adding row num less than 10 million, is that it has to do with the pagination of data, how the data is retrieved, and then you paging through it. And I know that a number of people have raised questions about this. Dennis, I know that you can remove that value for the row num, and I think that in some cases that will improve performance. You've probably done some playing around with it. But probably the best thing, if you haven't done it already, is to come up with a simple case that reproduces the problem and take it to the Apex forum or on Twitter, just hashtag #ORCLApex, and the Apex team and the developers and community will jump all over it. So that's what I would say is like steps going forward. I don't think it's a problem specifically to table functions. I think you've encountered it with a table function. So I don't know your comment, Dennis. There's F open close in terms of Apex recognizing that there's a table function. Is that what you're alluding to? That Apex should be able to tell?
Okay. The Apex runs it a select star from F where row num dynamically. Okay. And have you tried running that for your table function just in SQL Developer or something like that, Dennis? Yes.
Yeah, he said it was much faster.
Yeah, and it's okay.
And have you taken it to the Apex forum on OTN or anything else?
Yes. Okay.
And you've been very happy with the results. Watch. No.
Actually, you found the solution. Okay, go on then.
Wait a minute. You've been leading us along and you have a solution?
Go on, tell us.
Will Dennis share the solution?
Okay. He's got us holding on,
Dennis, you can even unmute if you want to get rid of property. Was that the maximum number of rows?
Of a report.
Okay, so yes, one thing that I've run into this on the dev gym itself, which is my main Apex development environment, is that I believe that by default the value is put in there for the report, the maximum number of rows, and then it will affect the SQL that's generated for the report, and you can simply remove that value and improve performance. Okay, but I don't think that's got anything specifically to do with table functions, just with the way that those reports work. So watch out for that. Would a SmartDB approach to Apex involve creating a table function for each report? That is, each report based on select from my function. I believe so, Eric. I believe that that's what SmartDB would suggest to you. I have recommended to my SmartDB counterparts, Bryn, Tone, that views are an okay part of SmartDB. Never directly go after tables, but to be able to select from views makes a lot of sense. And so I think it should be a part of that architecture. But to me, it's not a matter of whether it's right or wrong, whether it's 100% SmartDB or not. The main thing is to take the principles of SmartDB, which is to protect your data, build APIs around your data so developers can't mess with it. So you have high security, high performance, high data integrity, strong maintainability of your code base. And in that case, I think selecting from views in Apex is a fine way to go.
Yeah, and I think there's a lot of other tools as well, particularly if you look in anything that does reporting, kind of like Apex does. Quite often they work a lot better if they've got access to either at least a view, because you then don't run into any of these issues where the tool generates some extra SQL, causing performance problems, or it's less likely.
Good point. So Dennis, I would say in terms of using SmartDB, I don't think Bryn would like my phrasing here, but use it smartly. Figure out what works for you. And when you hit roadblocks, obviously you don't just give up. You don't try to push an architecture into a tool that doesn't fit either. You could say, well, therefore I'm not going to use this tool, because I want to follow 100% SmartDB, and you can make that choice too. But it's true that in Apex right now, you can't do 100% pure SmartDB as Bryn and Tone have defined it. And you know what? That's okay. You can still make a lot of smart usage of the database through Apex, obviously.